Let's look at this limit and let's make a conjecture about it. Let's make a guess. Instead of drawing a picture, let's kind of reason our way through this, okay? What's going on? I'm looking at the function 1 over x, and x is getting closer and closer to 0 from the right. So let's imagine what that looks like on the x-axis. Here's 1, here's 2. If I'm approaching 0 from the right, I'm approaching 0 that way. So let's see, I'll go through 3, 2, 1, and so forth. Let's start out with 1. 1 over 1. Okay. So x is approaching 0 from the right, so it goes through 1. Then maybe it goes through 1/10. Or, I'm sorry, through 0.1. Okay, because it's getting closer to 0. So in other words, x gets closer to 0. You still have 1 over 0.1. What about when x gets even closer to 0? Like x goes through 0.01. Well, what about whenever we get even closer to 0? And even closer, 0.0001. Well, give me these values. That's 1. That's 10. That's 100. This is what? 1,000. And this is 10,000. What do you notice about this is my x values get closer to 0 from the right. This whole function does what? Gets larger and larger, right? Now we're through an x value of 0.0001. What if we get even closer to 0? 0.0000000000001. Well, as you can imagine, this number right here is going to get larger and larger. So what happens as I get closer and closer to 0 from the right here? My function gets larger and larger. My output gets larger and larger, and we can guess that it goes off to infinity. In fact, that one does go off to infinity. Let's look at section 1.2, computing limits. So in 1.1, we kind of made a guess, kind of like we just did with this problem right here. Now we're going to look at more formal ways to calculate limits. All right, your book talks about some basic limits. Let a and k be real numbers. Then it has a, b, c, and d. And it talks about the limit as x approaches some number of a constant is equal to that constant. Limit as x approaches some number of x is equal to that number. We just looked at this one. Limit as x approaches 0 from the right of 1 over x. They're telling me indeed it is infinity. And they're saying the limit as x approaches 0 from the left of 1 over x is negative infinity. So let's memorize all of these. That's why I have stars by. It's going to help us out for the rest of the semester. All right, find the following. Limit as x approaches 3 of x. That would be this case, right? Notice the 3 is in the place of a, and our function is x. So what do we do then? We just substitute in 3 for x, and we say that this limit is equal to 3. How about the limit as x approaches a to 5? That would be this case. Notice how you have a constant that's 5. So as x approaches some number of a constant is equal to that constant. So this would be equal to 5. And part C, limit as x approaches 0 from the left. Could kind of reason my way through it and make a guess, but this tells me right here this limit is indeed negative infinity. So I'm just going to put negative infinity. All right, let's look at this now. A theorem in your book says, suppose that the limit as x approaches a of f of x is equal to L1, and the limit as x approaches a of g of x is L2. That just means those limits exist in some number. All right, the limit, if you're trying to find a limit of two things being added together, two functions being added together, just find the limit of each one and add them. Same thing with subtraction. Same thing with multiplication. If you're trying to find the limit of two things being multiplied, find the limit of each one, then multiply. Same thing with division. And let's look at this radical. The limit as x approaches a of some radical, or a function inside a radical. This says you could bring the limit to the inside of that radical, calculate that limit if it exists, then take the nth root of it. And finally, we have this. If we have some constant times our function that we're taking the limit of, you can pull the constant out to the front of the limit sign, calculate that limit, then multiply by the constant. Then your book talks about this is also, these statements also hold for as x approaches a from the left and from the right. All right, let's look at an example here. Find each limit. Find each limit. All right, so what do we have here? We have the limit as x approaches 7 of x squared minus 5x plus 1. Well, that's the limit of things being subtracted and added. It's the function x squared minus the function 5x plus the function 1. So we're going to use those properties here. Remember that property said if two functions are being subtracted, you can take the limit of each one. So we're going to say the limit as x approaches 7 of the first function minus the limit as x approaches 7 of the second function, 5x. Then we have another addition here, so we can say plus the limit as x approaches 7 of that 1. All right, let's look at this one. X squared is just simply x times x. So that's the limit as x approaches 7 of x times x minus. Now this limit as an x is multiplied by cos to the 5. So what I could do is I could pull the 5 out to the front, say that's 5 times the limit as x approaches 7 of x. Plus, what is this? The limit of a constant. It's just that constant 1. That was one of the ones we had to memorize at the beginning. Now let's look at this part. We had that theorem that said if two functions are being multiplied, we could take the limit of each one and multiply. So let's take the limit of x and multiply it by the limit of x. And of course we need as x approaches 7 here and here. Minus 5. What's the limit as x approaches 7 of x? Well, that was one of the ones we had to memorize at the beginning, right? Remember this sheet? Limit, make sure y'all can see it, as x approaches a of x is that value of a. So if we have x here, we sub in that a value. We have what? X here, sub in that a value 7 plus 1. Well, y'all just told me what the limit as x approached 7 of x was. Y'all told me that was 7. So this would be the same thing. So with that, minus 35 plus 1. And you just turn it into a calculation problem at that time. That's what? 49 minus 35 plus 1. What's 49 minus 35? That'd be what? 14 plus 1 is 15 is that limit. Let's look at B. Limit as x approaches 3 of this radical. Remember what they said in that theorem? They said, let's try to bring this limit to the inside of the radical. Now we have the limit of two functions being added. So let's separate that in the limit of the first one plus the limit of the second one. So we have the limit as x approaches 3 of x plus the limit as x approaches 3 of 1. Now what's the limit as x approaches 3 of x? Just 3 sub in. What about the limit as x approaches 3 of 1? It's 1. So that's square root of 4, which is 2.